divide by a fraction, multiply by its reciprocal. We are going to use that in pretty much every problem in this section. So what we do to one side of the equation, we must do to the other. I can't only multiply by the reciprocal on the left. I have to multiply by the reciprocal of that fraction on both the left and the right. So in this original equation, what is being done with this negative 2/7 and the n? What operation? Jacob? Multiplication. And we know that to undo multiplication, we have to divide. So if I divide by negative 2/7, that's the same as multiplying by negative 7 over 2. Well, if I multiply the left by negative 7 over 2, I have to multiply the right by negative 7 over 2. And we know that any number divided by itself or multiplied by its reciprocal is 1. Or if we multiply those together, we get 14 over 14, which gives me a value of 1. So I have 1 times n. And now I need to do the other multiplication. So I can rewrite this as negative 6 over 1. Is there anything that I can simplify before I multiply this out? And what does that simplify to? So 6 over 2 is the same as 3 over 1. So now I have negative 3 times negative 7 over 1 times 1. And I get a final answer of n equals 21. So if you don't have this written down, or if you have it written down incorrectly, you should be fixing it as we go, so that when you go to take a quiz over this and you get to use your notes, you have the right work. So our value is n equals 21. So dividing by a fraction, same as multiplying by its reciprocal. We've done this before. It's not anything new. So now we have this problem here. Go ahead and open up your book to example 2 in section 3.5. And the first thing that I need to do is find this important information. So what is something that is important in this problem? Zach? I need to know the first 6-week grades, the first 3 6-week grades. What else do I need to know? Seth? So my question is asking me, what does he have to get on his final to get a 90 for the whole semester? What else do I need to know? Jason? And what? What am I taking the average of? So I need to find the average of the 3 6-week grades and the final exam. You don't calculate the semester average just with those 3 grades. You also have to include the exam in there. So now let's talk about what is my variable going to represent in this problem. Yes, Joe? What about the final? The score on the final. So my variable represents the final exam score, the score on the final exam, however you want to write it. So now I need to use this variable to write some equation. So we need to remember how to calculate average, and I need to write some equation that will help me figure out what do I need to get on my final. What is that equation going to be? So you have an example in your book that you should be looking at. Zach? I know that I want my final average to be 90. And to calculate that average, I take my 3 6-week grades and my final exam grade. I know what my 3 6-week grades are. I don't know what my final exam score is, but I still have to include that in my average. Yes? But how did you figure out your final exam score? But that's not going to tell you what you need to get for your final exam score. Right, but that's not what I need to get on. That's not the final answer. 90 is not the final answer for this problem. 90 is the average I want to get. So maybe I already have a 90, but I still have to take a final exam. So my question is, after I take this final exam, what do I have to get on this to keep that 90%? Because I still have to take my final exam. So I still have to factor that into my 4 scores. I have 4 scores, 3 6-week grades and a final exam grade that all go into my average. What's going to be my next step in this problem? Zach? Okay, and what can I simplify? I can combine these like terms. I need to simplify the numerator as much as I possibly can, so I can combine these 3 terms together. Do you have a number? 271. So now I have 271 plus x. I'm still just adding that x to the end. So I combine my like terms together. So now I have 271 plus x over 4. So I have to kind of think, again, we need to remember that that fraction bar is like a grouping symbol. So everything in the top is grouped together and everything in the bottom is grouped together. I can also write this as 1/4 times 271 plus x. These mean the exact same thing. When I multiply fractions, I multiply the numerator, and then I would multiply the denominator, which would give me 1 times everything in parentheses over 4 times 1. They mean the exact same thing. So what is going to be my next step in solving this equation? Seth? Multiply by 4. And I can either look at it, we know this fraction bar means to divide. The opposite of division is multiplication, so I can say I need to just get rid of this division and multiply by 4. Or I can see down here 1/4 times everything inside these parentheses, so I divide by 1/4, which is the same as multiplying by 4. So now, no matter how I look at it, 4 over 4 simplifies to 1 over 1. And same over here, 4 over 4 simplifies to 1 over 1. So no matter which version I look at, I now have 271 plus x equals 360. So now I've gotten rid of all the fractions just by multiplying by 4. What's my final step here in this equation, Alex? What score do I have to get on my final? So I may already have an average of 90 with my 3 grades, but in order to keep that 90, I have to get at least an 89 on my final. So I can get higher than an 89, but I need at least an 89 to keep that average of 90. Questions about that problem? All right, let's move on and look at the next type of problem. What's something important that I need to know from this problem? Jacob?
Split half the money on the ticket and a third of the audience.
Zach, what else do I need to know? What else do I need? Graham? All right, so I have my information. I know what question I'm being asked. What's my variable going to represent in this problem? What about the money? Jason? The amount of money that he brought. Pretty much all the time, the variable is going to represent whatever we're trying to find. Now, we did have those problems where we were trying to find two things. So we had to say our variable represents one of these things, and then find a way to use that variable to represent the second. So we have done that. But our variable is always going to represent what we're trying to find. This time I'm trying to find how much money I brought to the movies. Now I need an equation. Zach, you got an equation? Why don't you come write it up here? Come up and write your equation. What does the word of mean in math? What? To multiply. So when I see half of his money, I'm going to multiply 1/2 times the amount of money he has. A third of his money means I'm going to multiply 1/3 times the money that he brought. And I know he spent a total of $10. Now I got to solve it. I've written my equation, now I need to solve it. What is one thing that I can do first to solve this equation? Jacob? Combine like terms. Can I add these together the way that I see them? No, because I need common denominators when I add. What is going to be my common denominator in this problem? 6. So what do I have to multiply 2 by to get to 6? Where else do I need to multiply by 3? In the top. What do I do to the bottom? I got to do the top of my fraction. So I multiply the first one by 3 over 3. So I have 3 over 6x. What do I multiply the second one by? 2. All right, so now I have a common denominator in my fraction, and I can combine those like terms. Now I have 5 over 6x equals 10. What do I have to do to finish it up? Which is the same as Will? So I can divide by 5 over 6 or multiply by 6 over 5. Dividing by a fraction is the same as multiplying by its reciprocal. How can I simplify this before I multiply? Jacob? 10 over 5 is the same as 2 over 1. 2 times 6 is 12. 1 times 1 is 1. 12 what? Talking about money. Yes, Zach. What'd you do?
I still got the answer. Like, add the equation, and I think I flipped the 3, or the 1/3, the 3 over 1, and then multiply both sides. But you have 1/5 next to each. And then I added those to both terms. I got it 30 with 2.5.
Okay. Instead of multiplying both sides by 3 over 1, which is 3, what can I multiply by to get rid of both of these fractions? Because when you multiply by 3, we're still going to have 3 halves here. I'm still going to have a fraction. What could I multiply by that will get rid of both fractions? Instead of multiplying by 3, what one value can I multiply by that will get rid of both of these fractions? Think about what we did in the other method. I don't know why it's doing that. But think about what we did here. What one number can I multiply the entire thing by, Seth? Let's try it and see what happens. What property am I going to need to use on this left side? The distributive property. So I'm going to take 6 over 1 times 1/2 x plus 6 over 1 times 1/3 x. Can I simplify here? What can I simplify in the first one? Zach? So now I have 3 times 1 over 1 times 1. And what does it simplify to? 6 over 3.
2.
So 2 times 1 over 1 times 1. Does this look a little bit more simple? So I can either just create a common denominator and combine my fractions together, or if I see a problem like this, I can multiply the entire equation by that common denominator. And by doing that, now I've gotten rid of those fractions because I can simplify numerator and denominator, and now I just have whole numbers to work with. Now, the key to that is you have to remember to multiply each term by that number. So I have to multiply the entire left side by 6, and I have to multiply the right side by 6. So you just have to be careful that you're multiplying everything by that value. I'm not changing my problem at all. I'm just getting rid of those fractions. What I do to one side, I must do to the other. And as long as I follow those rules, my equation stays the same. 5x equals 60. What am I going to do to finish? Divide by 1 times x. 60 divided by 5 is still $12. We got the exact same answer both ways that we did it, and you can pick whichever way you think is easier. You need to make sure that you have this written down on your paper. I didn't write it down for fun. I wrote it down so that you have 2 methods to see that you can solve this problem. Yes? Because that's my common denominator. So if you think of that least common multiple, or that common denominator, and multiply by that, then it gets rid of both fractions instead of just one. Questions about either of those methods? False. So in the last section, we were dealing with fractions. In this section, we're going to have more variables, but our rules don't change. All of our rules stay the exact same. So let's take a look at this equation. P equals W divided by T. Power equals work divided by time. We are given this formula, and I want to solve for T, which just means I want to get T by itself. So right now I have P by itself, but maybe in this problem we're given P and W, so I need to figure out what T is. I want to get T by itself. What am I going to do to get T by itself? Jacob? Okay, if I multiply by the reciprocal, then this becomes 1, and I have P times T over W. Did I completely get T by itself? No, so that's a good idea. It's a good try for the first thing. Instead of multiplying by the reciprocal, what can I multiply by? Because multiplying by the reciprocal completely got rid of everything. Joe? If I just multiply by W, I'm going to get that P equals W squared over T. Because W is in the numerator. So when I multiply numerator times numerator, or numerator times denominator, now I get just more W's on that side. So another good guess. Let's try again. What else can I try to multiply by? P over W? Again, if I multiply by P over W, I'm going to get P over T equals P squared over W.
Are any of us like remotely close?
Yeah.
We got to multiply.
Okay.
Greg? I could multiply by 0, but that's just going to wipe everything out. I'm going to get 0 equals 0. Multiplying by 1 won't change anything. That's going to give me P squared equals PW over T.
Can we just like
I know we're trying to get T by itself, but where is T right now? It's not at the bottom. What do we call that? It's in the denominator. And when I have a number in the denominator, to get it out of the denominator, I'm going to have to multiply both sides by that value. Because now, T over T is 1 over 1, so I have W by itself. So now I have P times T equals W. If my goal was to get W by itself, I'd be done. But that's not my goal. My goal is to solve for T. Divide by what? P divided by P is 1.
by itself?
T is completely by itself. T times 1. So the time equals the work divided by the power. So this would be helpful if they gave me W equals this value, P equals this value. Now I substitute them in, and I can figure out what the time is. That's why we do this. Well, we would do this and then put the numbers into the problem.
If you wanted to get anything by itself in this, couldn't you just swap sides with them? So like if you wanted T by itself, you just swap it with P and you would go with W.
Yes, but that's not always how it's going to work. I mean, it just depends on the problem. To get T out of the denominator, I had to multiply by T, and then now the opposite of multiplication is division. So for this problem, it worked that way. If you have more variables in different places, it's not always just going to be switch them around. Because like when I wanted to solve for W, I didn't just switch W and P, because W equals P times T. So it just depends on what you're trying to get by itself. Any other questions on that one? All right, let's look at this last one. I'm trying to solve 4y, which means my ultimate goal is to have y by itself. We are going to do this over and over and over again when we start graphing lines. We're going to have two variables, x and y, and we're going to have to get y by itself. So in this one, I have three variables, x, y, and z. And I want y by itself. I still have to follow the same steps that I've followed up until now. I start at the bottom, I start with adding and subtracting, and then I work my way up. So what is going to be my first step when I'm trying to get y by itself? Alex? Subtract 2x, because I want this to be by itself. The first thing that I have to look for is addition and subtraction. 0 plus 1/2 y. Can I combine these together? They're not like terms. One has a z and one has an x, so I'm just going to write it exactly as I see it. I don't change anything. I can't combine them. I can't simplify. I leave it just like I see it. What's my next step? Jacob? I don't want to divide by 2 over 1. I can multiply both sides by the reciprocal, 2 over 1. Any number times its reciprocal is 1. 1 times y is y. What do I have to do on the right side? I have to distribute. 2 times z minus 2 times 2x. Is y by itself? Can I simplify anymore? I don't have like terms, so those have to stay separate. And there is my final answer. Nothing changes. Yes, we have more variables. Yes, we are using fractions. The same exact rules apply. It is no different than anything that we have been doing for the past 2 weeks. Questions about that one? There is your homework. You have about 5 minutes.